So yeah, notice a couple of things here. I put kind of the basic equation up there. So what you've seen so far is if there's an A out in front, if there's a number out in front of that sine or cosine, that's what's referred to as the amplitude changes, an amplitude change. That changes how high and how low the graph goes, right, from our basic graph. So what we're going to look at today, what you're going to see today is you're going to see a number that's in front of the x. And that's what's referred to as a period change, okay? What that does is it changes how quickly or how slowly the wave or the cycle goes. I kind of like to explain this as like visually, if you can imagine these waves kind of suspended in air, we could walk up to it and kind of smush it tighter together or stretch it. Yeah, if we smush it together, the cycle's it's gonna go quicker. If we were to pull on it, it would stretch it out and it would take longer in order to complete that full cycle. So that's what's happening here. It's kind of a way of thinking about it, okay? If you notice, I put an actual example here, the y equals sine of 2x. So the cycle moves twice as fast, so the period is going to be half as long. So that's just kind of something that it kind of helps you think about that, okay? There's a general formula that we use in order to determine what our new period is, okay? Our typical period is 2 pi, right? So we're going to take our 2 pi and we divide by whatever b is equal to, and that gives us our new period, okay? So what's going to change on our graph now when we're looking at period changes, what's going to change is our x-axis markers, okay? Yes, we're dealing with fractions, everyone's favorite thing. I'm going to talk you through, there are multiple ways of kind of thinking through finding what those x-axis markers have to be. I'm going to talk you through 2 ways that I find that a lot of students kind of like or prefer or help them think through the process. There are other ways, obviously, so if you're comfortable with kind of coming up with these values in a little bit different way, that's totally fine. Okay, but I'm going to kind of share 2 different ways to think through it. And it just depends on your preference in terms of when you're dealing with fractions, how you like to work, okay? All right, because if you notice, like on this first example, it's a basic sine curve, amplitude has not changed. So actually, I mean, we can go in here right away, we could draw in the whole curve. Let's go ahead and do that. 1, 2, 3, 1, 2, 3, 1, 2, 3. I'm sorry? What is the period? So the period for our basic sine and cosine graph is 2 pi, okay? What that's saying is that's how long it takes to complete a full cycle or a full wave, okay? Once we go from 0 to 2 pi, if we move to 2 pi to 4 pi, we're going to get that exact same cycle. So that shows us a full cycle of what the graph does, okay? And for sine and cosine, it's from 0 to 2 pi. Which is nice because, I mean, think about it. We got all of this from our unit circle, right? Which is from 0 to 2 pi. Okay? Thank you for asking that. Appreciate that. Okay. So we're going to draw our sine curve, but the key on this one is that we've got to figure out what our new x-axis markers have to be. Okay? So like I said, I'm going to kind of explain this in 2 different ways. There are other ways to think through this, but I'm kind of 2 different ways that most people think through this. So our period, we're going to start with 2 pi, but then we're dividing by 1/4. So dividing by 1/4, if we do keep it, change it, flip it, if you need to rewrite that as 2 pi over 1 times 4 over 1 to get your keep it, change it, flip it, then that's telling us we're at 8 pi there. Okay? So I want you to think about the fact that this is getting divided into 4 equal parts, 4 equal distances. So this 8 pi, it's pretty easy to figure out pretty quickly what the other values have to be. But I want to kind of talk you through the process of how you do this mathematically also, because I'd rather work with the simpler numbers first and then kind of go back and look at some more challenging numbers. Okay, so one method is that we're always going to find our new period first. So our new period for this particular graph is 8 pi. From there, we need to find each of these particular markers, those other 3 markers. We know the other one's at 0 pi. So first method that I'm going to explain to you is what I refer to as the multiplication method. And we take our period and we multiply it times a half. I want you to think visually where that would be on our number line. If this is the full period, then half would be here. So when we multiply by a half, it gives us, we have to kind of jump to that spot. It gives us our halfway point, right? Okay, then from that number, we multiply by a half again. And that gives us, if you think about it, if we're going halfway to this particular point, then we're here. So that gives us our first value, our first hash mark. And then from there, if you think about the one that we're missing, this is at 1/4, this is at 2/4, this is at 3/4. So if we take whatever this particular value is and we multiply it by 3, then that gives us the third hash mark. Okay, so that's the multiplication method. Some people don't like it because you're kind of bouncing from place to place. You're going half, so you're jumping to here and then you're jumping to this first spot and so on. But if you multiply by a half and then by a half again and then multiply by 3, that gives you all of those. Solomon. Okay. So that's first method that I like to explain. The second is what I refer to as kind of a repeated addition. And this is going to involve adding fractions. We take what our new period is, so in this case 8 pi, and we're going to multiply it by 1/4 to get our first hash mark, right? So if we do 8 pi over 4, we know we get 2 pi. So that would give us this value right here. And then we know that has to be the distance that we continually progress along our axis to get to the other values. So whatever you get for that first hash mark, you're going to add that to itself. And that gives you the second hash mark. So that gives us 4 pi. And then if we add that again, that gives us the third hash mark. Okay? So some people prefer that method because it's progressive. You're starting at the first spot and moving in order. But other people don't particularly like having to add those fractions. So they don't particularly like that. So a lot of it just has to do with how you prefer dealing with fractions. If you're better at multiplying or if you're better at adding. Okay? Are there other ways of coming up with those? Yes. Someone in first period said, can't I just take the period and multiply by a 1/4 and then multiply by a half and multiply by 3/4? Yes. So lots of different ways, but I've found these 2 methods kind of tend to be kind of the methods of choice, for lack of a better way of putting it, okay? This example, I think, kind of simplifies things also, makes it a little bit easier to kind of see because the numbers are pretty easy to do figuring with. All right, let's go ahead and draw in our sine curve. Where do we start for sine? At 0 degrees, where are we? 0, good. So we're right at the midline, right? For sine, remember we start at the midline, and then where do we go? Yep, we go up to 1, and then back to 0, and then to -1, and then 0. Boop. There we go. All right, questions? Let's look at one that's a little bit trickier in terms of the math. And I'm going to do the successive adding first, and then I'll go back and show you the multiplication method just to kind of help. So you guys can kind of decide which one you think you like best. We're actually going to look at this one next. So let's do this cosine graph. So let's label, here's my 1 and my -1. 1, 2, 3. Okay, so to begin with, basic period, which is 2 pi, in this case 2 pi over 5. So that's our period. So that means that this last hash mark here is 2 pi over 5. And now I'm going to multiply that times 1/4. And if you want to think of that as 2 pi over 20 and then reduce that, you can. If you're okay with going and doing some cross canceling and saying that should be a 1, that's a 2, so we get pi over 10. That works also. Okay, so our first hash mark is pi over 10. Yeah.
How come I multiply by 1/4 again?
You multiply, but because what from the full period, from what our full period is, if we're doing this method, then we multiply by 1/4 to get that first hash mark, and then we're going to repeatedly add whatever that distance is. I don't know. Does that answer your question, Maya? Because if you think about where we are, like on the graph, the 2 pi over 5 is out here. That's our final, that's our last point that we're going to graph, the last hash mark. But we're trying to figure out what this first hash mark is, and we're dividing this into 4 equal pieces. So we can divide by 4, or we can multiply by 1/4.
Okay.
Maybe that helps a little bit in terms of better explanation. Okay, so first hash mark is at pi over 10. Christian, did you figure out what you were wondering about?
We're all confused. So we're adding another pi over 10.
Yep, that's what we're gonna do now, is we're gonna repeat it. Yikes, come back here. We're gonna add pi over 10 again,
What will that equal?
and that gives us 2 pi over 10, which you have to simplify that. So 2 pi over 10 simplifies to pi over 5. And then we're gonna add, to get the last hash mark, we're gonna add pi over 10 again. And so that gives us 3 pi over 10 for our last hash mark. So this one will be 3 pi over 10. So I want you to notice something. If you think you're gonna wanna, if you like this method of the successive adding, I want you to notice, when I wrote this, I did not convert that and simplify it here when I was doing my mathematics. I put my simplified answer over here, but I wanna keep my common denominator because then I have to add again. So that helps us. If I had rewritten this as pi over 5 and then I had to do plus pi over 10, I'm having to think about common denominator. I'm having to basically undo what I just did. So just kind of keep progressing along there. Write your simplified answers along here if you need to. Does that make sense? I hope.
One of those like V-shaped graphs.
No, it's not a V, it's a curve. But yes, it is going to start high. You are right. So let's put those points in. So you're right. At 0, Christian, it's going to start up at 1. And then at the next point, at this next hash mark, we're at 0, and then at -1, and then 0 and 1. And don't you dare draw it as a V. Like I said, I would rather you kind of over-exaggerate the curve, because if you make it look like a V, I'm counting off. Make sure these little arrows are going back down, that they are not going out and up and looking like they're wispy, flying away type thing. All right, let me talk you through the other thought process if you were going to do this using multiplication. So if you were to do the multiplication, you'd start with 2 pi over 5. You'd multiply by 1/2, which the 2's divide out, and so you get pi over 5. So that has you jump from last hash mark to the middle, which is the second hash mark. And then if you multiply that by 1/2 again, that gives you the first hash mark, which is that pi over 10. And then if you multiply that by 3 over 1, then that gives you this hash mark. So that's the other method that I usually show. Okay, Early, you had a question, sorry.
Oh, no, you're good. I just want to know what you thought.
Okay, yeah, go ahead.